Thank you, Biju, Prithvi, John, and all the young innovators. I'm a bit of an odd man in the group with a lot of gray hair. So our study is about bacteriophages, a novel approach to combat multi-drug resistant Pseudomonas corneal infections. This is a combined work of Amrita Biotechnology as well as the Amrita Institute of Medical Sciences. As you all know, infective keratitis is the second most common cause of vision loss, and we have anywhere close to 10 million people who are corneally blind. And among the keratitis, Pseudomonas keratitis is notorious. It has multiple mechanisms of resistance, intrinsic resistance to a lot of antibiotics, your routine antibiotics, most of them are intrinsically resistant. Then you have the extrinsic resistance. Then there is something called adaptive resistance, which comes because of the biofilm and the mucoid character and all that. So whatever it is, Pseudomonas is a bug which is dangerous, and more than 30%, and some of the studies close to 48% of the bugs are resistant to multiple antibiotics. So I think then another thing is the phages are viruses which need a host bacterium, and they're very specific to the bacteria. So I think India has some connection to the bacteriophages in that it was first described the water from Ganga and Yamuna had this bactericidal action. At that time, phages were not known to humankind. So it was reported, and it was there in the literature from 1896. So they reported that this water from these rivers have got bactericidal action. But it was Frederick de Herel from Paris who got this bacteriophage. He's credited with the discovery of bacteriophage along with Watt from UK. So he came all the way from Paris to India. He spent time in India. That time cholera was all around. And he gave phages to some villages, put them in the wells, put it in their food and all that, and found that the prevalence of this cholera infection was much less in these villages where it was used. Then it was very popular in Eastern Europe and even now, but it lost its prominence because of the emergence of antibiotics. So we had isolated a particular bacteriophage called AMP2. AM stands for Amrita and P for the Pseudomonas. It is from the wastewater from Kollam. As you see the structure over there, that is the genomic structure which was characterized, and that was actually given this name by the ICTV, the International Collegium for the Nomenclature of Viruses. So it is seen to be a phage against the multi-drug resistant Pseudomonas. So they had multiple types of these phages, AMP1 to 9, and they found that what in the in vitro studies what they found is that the cocktail of AMP2, 4 and 5 are the most effective. So the aim of a study was to look at the efficacy of the cocktail, this bacteriophage cocktail against multi-drug resistant Pseudomonas keratitis. So these bugs were isolated from various sources, mainly from this brackish water and all that. So this water sample was taken, put in equal amount of enrichment broth, then they have overnight culture was done, and centrifuging and then collection of the phages were done, then bacteria were filtered out, then there is a process of phage multiplication called this double agar overlay, and multiple methods which as ophthalmologists we don't know, and basically finally, phage pellets or concentrated phages were made in SM buffer and stored as high titer stocks. So to produce the corneal infection model, we use the corneoscleral rim, which is abandoned cornea. So we put this agar gel on the downside, on the endothelial side. Then we made the scratches on the cornea, and then kept a Trufine on top, and which was rotated up to 300 microns, 3 rotations, and it was made water sealed by putting cyanoacrylate glue. So it was a watertight container into which the Pseudomonas condensate was put. And followed by that, this phage combination was put, and it was incubated overnight. So at the next day, it was homogenized. The resulting suspension was spotted on LB plates. So 4 pairs of corneal buttons were used. One pair contains only the Pseudomonas, and second, the control pair, the phage treated pair will have the Pseudomonas followed by the phage treatment for about 8 to 10 hours. So in that, what we found is there is a remarkable difference between the colony counts between the, in the first pair. The similar story was seen in the second pair, third pair, as well as the fourth pair. The fourth pair, there is some yellow pigmentation because of the pyoverdine. So it was seen to be highly effective in killing multi-drug resistant Pseudomonas. And this is a Pseudomonas PA01 was a multi-drug species which was grown. So with the industry shying away from the investing in newer antibiotics, phage cocktail has got a real potential in the treatment of Pseudomonas keratitis. And there are certain off-label studies done in Georgia and all, in which people have traveled to Georgia and got these bacteriophage drops. But this AMP, this particular phage was prepared from India. It's a made in India phage. Thank you so much.